Okay, so today we're looking at exercise 3H question 3L from the textbook, which is this one highlighted here. We have solve each of the following for x, give exact answers. So we're solving for x, so we want to find that, and we've been working on quadratics, so let's see if this is a quadratic. So standard form of the quadratic equation is ax squared plus bx plus c equals 0. Okay. Now this looks a whole lot more complicated because it's got an additional variable in there, k, okay, but we still have coefficient times by x squared. We have a coefficient times by x, and then we have a constant on the end. So we are in the standard form where a is equal to 2, 1 minus k, b is equal to negative 4k, and c is equal to k. So if we have that, that means we can use the quadratic equation to solve for x. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now all we have to do, okay, the only hard part was recognizing that it's still a quadratic, finding our terms. Okay. All we have to do is substitute and then do a whole bunch of algebraic simplification to solve. So we get x equals a negative 4k plus or minus the square root of negative 4k squared minus 4 by 2, 1 minus k, times by c, which is the k, all over 2 by 2, 1 minus k. Okay. So we'll start simplifying. So we get negative, so we get 4k plus or minus, let's do the square root. So let's use our indices laws to come in here. So that goes, 2 goes to the k and goes to the 4, so we end up getting 16k squared minus, okay, and what we'll do, let's expand through this way. We'll expand the 2 into here and then the 4 all in one step. So 2 times the 1 is 2 times the 4 gives me 8. 2 times the k is 2k times the 4 gives me negative, and I've left the negative in front of the bracket, okay, so we keep this negative, so that's going to be negative 8k with the k on the end. Because I've done this problem before, I'm actually going to leave this 2 out the front and then go to 1 minus k. Get 4k plus or minus, okay, 16k squared we're going to leave for now. Okay. Let's simplify this finally through, so we get minus 8k plus 8k squared all over, and I'm leaving the denominator the same. So and you might notice, 16, we might be able to do something with that, but we've got R8 over there, so we're not going to use surd laws to try and simplify this surd down. It'll stay a surd in the answer. We've got 16, not that. We had 16k squared plus the 8k squared, so we've got 24k squared minus 8k all over 2, 1 minus k. Now we can take out a common factor inside this and do a little bit of simplification of it. So 4k plus or minus. Okay. If we take 4, this common factor out, okay, we get 4, 6k squared minus 2k. 1, 2, 2, 1 minus k. And you might be realizing now maybe why I've left that 2 there, because we get 4k plus or minus. Now the square root of 4, we can take it out using thirds. That gives us 2 square root 6k squared minus 2k all over 2 minus k. And then we can do this simplification with at least the 2. So 2's gone, 2's gone, that's going to turn to a 2. So our final solution is 2k plus or minus the square root of 6k squared minus 2k all over 2 1 minus k. And that's it. So it doesn't look very neat, it's still quite a large expression, but that's it, that's as far as we can go. And if we put any k value in that, that will actually work for any k value we put back in our original expression. That's it.